Hello, Algebra 2. This will be the final video slash review for the final that you'll be taking tomorrow. As you know, tomorrow at 9 a.m., from 9 a.m. to 12 p.m., your window for your testing will start. It will be on Pearson, so just check your Google Classroom. Tomorrow 9 a.m. it will be posted for you guys to see. Once the final begins, as long as you turn in it by 12 p.m., you can log in anytime you want. If you want to have the most time for yourself, come at 9 a.m. You can come at 10 o'clock, 11 o'clock. It's up to you. As long as you finish it by 12 p.m. There will be 30 questions in total. Some of them are multiple choice. Some of them are like those checking select all that apply boxes. Some of them will be just typing in the answers just number wise. Then it says rounded to the nearest tenth. 100th. Just follow instructions accordingly. This will be the last grade, a test grade, plus the finals review, the 2 quiz grades that I'll be inputting. Hopefully that all of you guys will be able to do well in this and make sure that you guys end up with at least a B in this class for the marking period at least. Okay, so let's first begin going over the review. Number 1. Explicit and a recursive formula of a sequence. One of the more recent topics that we have done, and you will see this in the beginning couple set of the questions, find the recursive formula of the following sequence. So for these guys, you have to find out what's the pattern. Seems like I am adding 4 each time. It's not subtracting 4 because if it was subtracting, my negative numbers will be getting bigger. And this is multiplied by -2. So the way to do it is a recursive formula always utilizes what we call the previous term, a sub n minus 1. So what I'm going to do is the a sub n is equal to a sub n minus 1, the previous term, plus 4. And the a sub the first term is -16. You need to state both of them like this. A sub first is 3. The a sub n is the previous term times -2. Or just leave it as -2 times a sub n minus 1. That should be the answer. How many terms n are there in the following sequence? For this one, you need to find out using the explicit formula. This one, it seems like I am adding by 0.8 each time, so we call this the arithmetic sequence. Arithmetic explicit is a sub n equals a sub 1 plus common difference times n minus 1. So we're really looking for the value of n here. The value is 70.1, and the first term is 0.5. Common difference is 0.8. So what we have to do is, we first need to subtract away 0.5 on both sides. And once I do that, I get 69.6 is equal to, let's see, 0.8 times n minus 1. Okay? So once I have, oh, I'm sorry, this is, 69.6. Divide by 0.8 on both sides. And then you get n minus 1 is equal to 87. Add the 1 on both sides, you get n is equal to 88. That should be the number of terms. Alright, so the next one here is the geometric sequence, and how do I know that? It's because it gives me a common ratio of 3. So the explicit formula is a sub n is equal to a sub 1 times the common ratio r raised to the power of n minus 1. So it's a sub n is 8748 is equal to the first term, which is 4, times common ratio of 3 to the power of n minus 1. So what I'm going to first do is I have to divide both sides by 4 to cancel this out and get 8,748 divided by 4, which gives me 2,187 is equal to 3 to the n minus 1. Now, if you guys remember how to get these exponents to solve for, what we need to do is we need to be using logarithms. So to bring n minus 1 into the front, I need to take log of both sides. So I'm going to start to write down here. So it will be log of 2187 is equal to log of 3 to the power of n minus 1. But the thing is, the n minus 1 now comes to the front. So it will be n minus 1 times log of 3 is equal to log of 2187. I know that it's really hard to write down here, but I'm gonna just zoom in and do it this way then. Okay, so n minus 1 log of 3 is equal to log of 2187. This is called the power rule, where whatever was in the exponent, like right here, it comes to the front. Okay, so then what I'm going to do is divide both sides by log of 3 like this. So n minus 1 is equal to log of 2187 divided by log of 3. Now for those of you guys who have the graphing calculator and you can use it, you can just call the base to be 10 and it should be fine. And then what I get is 7, so just add 1 on both sides and I should get n is equal to 8. So my final answer for this question should be n is equal to 8 for the second part. Okay, now they're all good questions because it goes right into exponential and logarithmic. Rewrite each term from exponential to logarithmic. What we do is we have to just do log of base b, and then whatever the output is, it becomes my input, and then that equals your exponent a. That is how I rewrite an exponential form into a logarithmic form. We call this the base, we call this the exponent, and we call that the output, right? Well, if you want to go from exponential form to a logarithmic form, the base is that little small guy right there. This is your output, and this is your exponent. So we kind of swap places exactly. So here, how do I write that? Log base x, because that is the thing that's getting raised by, of output 178, it gives you the exponent y. Same thing happens here when we're going backwards. It's the base raised to that power gives you the output, which is m. X raised to the power of y gives you 191. That should be it. All right, next question. Expand each logarithm using one or more logarithmic properties, power rule, quotient rule, and product rule. And then we want to simplify each logarithm by condensing it into one singular logarithm. Okay, so remember that as long as I have the same base, if I'm adding the two logarithms together, that means it's log of b, ac, you have to multiply them. And if it's being subtracted, we know that's log base b of a over c. And if it's log base b of a to the power of c, that comes into the front and say that's c log base b of a. We call this the product rule, call this the quotient rule, call this the power rule of the logarithms. That's what this power rule, quotient rule, and product rule is all about. So first, when I'm expanding this guy, I see this big division sign, which means I need to separate this and this entirely into two separate logarithms and say log base 2 of 9x to the power of 10 minus log base 2 of y squared because it's being divided by. Then what do I need to do is I need to separate this one once again. It's 9 times x. So if I'm separating the 9 and the x to the power of 10, this becomes log base 2 of 9 plus log base 2 of x to the 10th minus log base 2 of y squared. Now that's all good and all, but there's last step that needs to be involved, which is the power rule, which states that every exponent can come to the front. So my final answer would be log base 2 of 9. Well, this will stay the same because there's nothing to do with that. Plus 10 times log base 2 of x. Notice how the 10 now comes into the front. Minus 2 log base 2 of y. This would be my final answer for the logarithmic properties. The second one, what I'm going to do is I'm going to separate 4a and 5. This might be a little bit easier to do. Notice how I did the minus sign because it's being divided by. Then the 4 and the a, they're still being multiplied together, so I can separate them and say log base 2 of 4 plus log base 2 of a minus log base 2 of 5. And if you know, this log base 2 of 4 is the same thing as saying 2. So whenever you can simplify that into very, very nice numbers, just write it down. This should be the final answer. This is the same thing as saying log base 2 of 4, just like I said. All right, next question is, now I'm going backwards where I'm given the elongated version, I'm given the separated version, and I'm now trying to put all of them together and combine them. So let's combine these two first together and say log base 3 of a times b, because plus sign means I need to multiply. Then it says minus 2 log base 3 of c. Now, even before we do any product or quotient rule, it might be a good idea to put all of these power rule applied first and make this into a c squared instead. So it's minus log base 3 of c squared, and you know if it's a minus, it's a quotient rule, so my final answer should be log base 3 of ab over c squared, divided by c squared, basically. Okay, and that should be one singular logarithm. Next, 4 log, so this one power rule first, and then you should pretty much do log base 5 x to the 4th power first. And then I'm just going to go in by order. So here what I'm going to do is log base 5 of x to the 4th power minus log base 5 of y. That means I'm going to use the quotient rule and say log base 5 x to the 4th divided by y. Then plus log base 5 of z. Plus sign means product rule, so just have to multiply them. Multiply means, guys, it's z multiplied to the x to the 4th power. But this is z over 1, so 1 times y is just y, so just leave the denominator alone, please. That should be my final answer for the second question. Okay, so logarithmic properties is done. Next question. Okay, solving radicals. Alright, solve for each variable indicated. Please check for any extraneous solutions. For all of these, you're just going to be squaring it. Not right away though, like the second one is, because you gotta get, once the square root is completely by itself, then you want to square it and get it out of the way. Square root and square just cancels out, so 4n plus 8. But this you have to FOIL. So n squared plus 6n plus 9. Well, how did I get that? n plus 3 times n plus 3. First, outer, inner, last. Distribute them, you should get this. Doing this for a long time. If it's a quadratic situation, guys, we need to move everything to one side. So it'll be 0 is equal to 4n minus 8, 4n minus 8. I'm going to subtract both of them from both sides. Get n squared plus 2n plus 1. And this will just leave it to be at 0, right? Remember, when we're solving quadratics, we want to move everything to one side, and then we want to factor if possible. If not, then use quadratic formula. It's one of those two choices. Luckily, n squared plus 2n plus 1 can be factored. It's n plus 1 times n plus 1. So n just equals negative 1. Now, what we want to do is we want to check for any extraneous solutions. We want to plug back in. So if we plug n plus 1 back into here and here, this becomes negative 4 plus 8 is equal to negative 1 plus 3. That becomes square root of 4. That becomes 2. 2 equals 2. So that checks out. Great. This question, I cannot square this entire side right away like I said. I need to get this guy by itself first and get similar fashion as the first question that we had. And then what I want to do is then I want to square both sides. So I get negative 3n plus 10 is equal to n squared minus 8n plus 16. Well, how did I get all this situation? Just FOIL that out, please. n minus 4 times another n minus 4. First, outer, inner, last. You should get m squared minus 8n plus 16 when you combine them. Then I'm going to move everything to one side in which it contains the m squared. M squared should not be messed with. So move everything to one side like this. And what I'm going to end up getting here is that it's m squared minus 5m plus 6 is equal to a 0. Luckily, that's also factorable. m minus 3, m minus 2 is equal to a 0. So m is equal to 3, m is equal to 2. Am I done? Not quite, because I still need to plug it back in to make sure that I do not get any extraneous solutions. So I probably will have to do these two questions separately, but I'm going to just plug in right here. 4 plus square root of 3 times 3, I'm plugging in the 3 first, plus 10 is equal to a 3. Now, does that make sense? This would give me 4 plus square root of 1. Well, that's 4 plus 1, which should equal 5, but 5 does not equal 3, so that is complete gibberish right there. So that's an extraneous solution. So we call this no good. So that's called extraneous solution. So the only solution that you're going to get is m is equal to 2. Let's verify that. 4 plus square root of negative 3 times 2 plus 10 is equal to 2. Does that make sense? 4 plus square root of 2 is equal to a 2. Let's see. So, I'm sorry, 4 square root of, what is that, negative 6? That's 4. So 4 plus 2 is equal to a 2. So 6 is equal to 2. Well, that even doesn't make any sense either. So neither of those two will be working out, unfortunately. So then we call both of these to be extraneous solutions. So then what does that mean? It means that we won't have any solutions whatsoever. So no solution. Okay. All right. So I just want to double check, make sure everything is here set up correctly. Yeah, I don't think there's going to be any problem with this. Yeah, so both of them is going to be extraneous solutions, and neither of them will work out, unfortunately. Okay, so let's see. All right, so here I duplicated the slide so I can go over the other two questions. So we have the answers for number 4. We're going to go over number 5 for this one. Ooh. All right, so for number 5, we have solved for the rational exponents. So for rational exponents, what you want to remember is take reciprocal exponents on both sides. So we want to take, if it says 3 over 4, for example, we want to say, I want to take 4 over 3 as an exponent on both sides. Before we do any of that stuff, just like how we did this question where I moved the 4 to the other side, we need to add the 1 on both sides like this. And get this to be 27 is equal to 27x to the 3 over 4th power. This entire thing raised to 3 over 4th power. And then, because this thing that's being raised to the power of 3 over 4 is by itself, that's the key word here, then, only then, I can take both of them to be power of 4 over 3. So if I rewrite this, I'm going to take both of them to be 4 over 3rd power on both sides. So these two would cancel each other out completely. And what 27 raised to the power of 4 over 3 is going to give you 81. Okay? I believe I did that correctly. 4 over 3. Yeah, it's going to give you 81. That's going to be 27 times x now. Divide both sides by 27, and then what I'm going to get is x is equal to 3. Okay? All right, next. Here, my very, very first step that I need to do is, of course, I need to add the 3 on both sides. So I can get this guy by itself. That's the key here, the key word here. Then I'm going to get 8 minus 2x raised to the power of 5 over 4 is equal to 32. Then what am I going to do? I am going to simply take both sides of the equation, raised to the power of 4 over 5. Just raise them to the 4 over 5 because then those will cancel each other out. I get 8 minus 2x is equal to 32 raised to the power of 4/5. If you type that into the calculator, I believe what you're going to get is 16. Okay? So if I rewrite this, 8 minus 2x is equal to 16. That's just a simple algebra questions. Negative 2x is equal to 8. So x must be negative 4. That should be my final answer. Okay. All right. So solving rational exponents. Remember, radicals, make sure you get it by itself, the radical by itself, and then square it. If you're getting rational exponents, make sure that you raise it to the power of reciprocal exponent. Those are the key magic word here that you need to consider. All right, next, domain and range. Write down the domain and range of the given functions. So domain is all set of your x values, and range is all set of your y values. Okay, so now what I'm going to do here is I'm going to take a look at this sideways parabola, and then I'm going to write down what the number of, the range of x values that's present within this function. But as you can see, my x value does not go more from -2 here. So it's everything that's contained within this side of the equation. So I'm going to say, you know what? X is anything that is greater than or equal to -2, and that's it. Because anything that's less than -2, which is on the left-hand side, right here, it's not going to work because there's nothing present. Range. Range is the set of all your y values. Okay. Now I know you might say, okay, it only goes from here to here, but look at the arrow sign. The arrow sign continues go down this way and that way, and in which it's going to infinitely reach up and down. So what am I going to say? Y reaches all the way to -infinity, all the way to +infinity, and there's another way to indicate this. It's all real values, or all real values. I'm writing down so many different ways in which you can write down the answer. That's 1, 2, 3 different ways in which you can write down the answer. Y should all be present right there. All right, next question. This is kind of like a roller coaster ride. Let's talk about the domain first. It seems like the domain, it doesn't give you the arrow signs as you can see right here. For these two, arrow signs indicates that it goes on infinitely forever. For this graph, it only starts from here and ends up being right there. So my domain is from 0 to 6. My range goes from 18 to -6. So -6, y is less than or equal to 18. That should be the way how you write the range. All right, number 6 is done. Number 7, multiply. This is just simply asking your FOIL. I just don't want you guys to make a mistake on this because it might seem a little bit difficult or challenging, but it's really not. So first is 1 times 2. Outer is 1 times -10, so it's negative square root of 10. Inner plus 4 times 2. That's 8 square root of 10. Consider the square root of 10 as like a variable. I have seen so many kids who try to multiply 2 inside the square root as well, but that is not correct. So it should be 8 times square root of 10. And the last one is 4 square root of 10 times another square root of 10, but it's negative, of course, so you just have to put a negative sign in the front. What's square root of 10 times square root of 10? That's square root of 100, right? But that just simply becomes 10, so my final answer would be -40. So if you're to consider this as x, I have -1 square root of 10, and I have +8 square root of 10. How many square root of 10s is that? That's +7 square root of 10s, because that's -1 plus 8. Just leave the square root of 10 alone. It's not like they cancel out or anything. They just stay there. Consider as a variable. If you do 1x plus 8x, you see that's 7x, right? Same thing happens here. And that's 2 minus 40, so it's minus 38. This should be my final answer. This one, first, outer, inner, last. What I'm going to do here is I'm going to do 5 square root of 3 times 5 square root of 3, so it's 25 times 3, minus 5 square root of 3 times square root of 2, so it'll be 5 square root of 6, because guys, square root of 3 times square root of 2, the square roots can be put together. So 5 now just stays the same. And it's negative because it's minus on the front of the square root symbol. Plus square root of 2 times 5 square root of 3 should give you plus 5 square root of 6. And the last one is minus square root of 4. These two cancel each other out because it's minus and the plus of the exact same value. So 25 times 3 gives you 75. Minus square root of 4, which is 2. My final answer should be 73. Okay. All right, number 8. Okay, so if you have a question about how, I have a square root, but how it come out to be a perfect number, well, that's because we have square root, we basically have the same exact numbers, but it's a plus and a minus. So that because the middle part's getting canceled out, the other two are going to give you real numbers, and hence your answer is going to be a real number. All right, number 8, change the radical expressions into rational exponents. Remember, whatever this number is, just put it as your denominator. That's it. So denominator of what? Well, this is same thing as saying 6 root of 10 to the first power. So putting 6 underneath that will give you 10 1 over 6. This one, the numerator is 5, so put the 4 underneath it, so you get 2 to the power of 4 over 5. That's it. That's literally all you have to do. Rational exponents means fraction exponents. Radical means just having a roof over the top of the number, which is a square root symbol. Okay? All right, next. Change the rational exponents into radicals. So all I got to do is now bring the denominator to the front, say cubic root of 2 to the 5th. The 5th still stays there. Bring the cubic root to the front and get cubic root of 7 to the 4th power. And that's it. All right, solving rational functions. Now, solve for x. I'm going to cross multiply for every single one of these questions when I have it in this format. For this one, I have to do a little bit of a work in before because I need to add them first and have it as a fraction equal to a fraction at that stage. Well, the problem is I have two fractions on one side. I got to combine them two first. When it comes like that, you got to combine them first, but we'll talk about that later. First, let's talk about this. I'm going to cross multiply them. So 3 times x minus 1 is equal to 4 times x plus 2. 3x minus 3, make sure you distribute them. 4x plus 8, make sure you distribute them. Subtract the 3x, subtract the 8, so x should be negative 11. Next, for this one, I have to do what we call a common denominator, right? Okay, so I'm going to rewrite the question up here. 2 over x plus 2 plus 1 over x minus 2. Forget about 3 over x for now. What's my common denominator here? I got to multiply this side by x minus 2, x minus 2. Got to multiply this side by x plus 2, x plus 2, because that's the way to get a common denominator. So once I distribute the top here, I get 2x minus 4 over x minus 2 times x plus 2, plus x plus 2, because that's 1 times x plus 2, over x minus 2, x plus 2. So since now I have a common denominator, I can add them up and say that's 2x plus x, which is 3x, negative 4 plus 2, which is negative 2, x minus 2, x plus 2. So that is going to be the combined version of that. But I'm still not done because now I can cross multiply. Okay? So here I'm going to write down my answer. Cross multiply this way, cross multiply that way. I get 3x squared minus 2x is equal to 3x squared. And then if I simply multiply this, I get x squared minus 4 if you FOIL it out. So that might be a lot easier for me to do. And then I get minus 12. Because 3 times x squared, 3 times negative 4. And what happens is the 3x squared from both sides will cancel each other out beautifully. And my final answer is x over x is equal to a 6. And that's it. All right, next question. All right, simplifying rational exponents. Simplify the following. Also write down the domain restrictions. Okay, so for simplifying, all they're asking you to find is factor them. I told you guys whenever you have a rational function, your first step, your go-to step, should always be to first factor, factor, factor. The first question, I get x minus 4, x plus 3. How do you get that? Two numbers that multiply to give you negative 12, but ask to give you negative 1, negative 4, and 3, right? We've done this countless times. If it's one thing that you guys have to learn from Algebra 2 class is how to factor at least these easy ones right away. This one is x plus 3, x plus 5. Well, look at that. X plus 3 cancels out, so I can simplify it as x minus 4 over x plus 5. The domain restriction, you're going to say x cannot equal negative 5, and x cannot equal negative 3. All that comes from this one and this one. Okay? Because your denominator cannot be 0. What that means is each of these two separated factored format, they can't be a 0. Whatever that's canceled out, that becomes a whole. Remember that? That becomes a whole, but that still means that there is no value present in that x value. So the x cannot happen at x equals negative 5 and cannot happen at x equals negative 3. So those two, you should say that it's not going to be present. All right, next question. A squared plus 5a plus 4. That should be a plus 4 times a plus 1. The denominator should say a plus 4 times a plus 5. These two should cancel out. My simplified version is a plus 1, a plus 5, with the domain restriction of can't be a negative 4, can't be a negative 5 coming from the denominator of that. Okay? All right, number 12. Multiplying and dividing rational expressions. So dividing always means keep, change, flip. Keep this, change the sign to a multiplication, and then flip this over. So rewrite it as n plus 3 over n plus 2 times n minus 1 times n minus 1, because that's the same thing as saying squared, over n minus 1 times n plus 3. Cancel it out. What can I cancel? Well, from vertically, n minus 1 over n minus 1 can be canceled out. Diagonally, the n plus 3's can be canceled out that way. So my simplified format would be n minus 1 over n plus 2. The domain restriction has to come from this up here, guys, not from here. So here, the domain restriction should say that n cannot be negative 2, n cannot be positive 1. That should be it, not here. This I don't care about because I've already flipped it. Your original function is what you should care about in terms of your domain restrictions. That should be my final answer. Next question. This one you don't have to do any keep, change, flip. You just have to take it as it is. The stupid thing is about this is that both of these could be canceled out right away. So my final answer is just 2 over 3. But I need to sell my domain restrictions, right? Well, the domain restriction for this, there isn't none because your denominator is straight up 3. There's no v value that's going to give you the denominator as 0. There simply can't happen. What really has to come from is this. So you still have to factor it, even though that's really pain. It's v minus 3 and v minus 9. So the v cannot equal 3, v cannot equal 9. That's going to be my final answer. All right, next question. Horizontal and vertical asymptotes. Okay, so horizontal asymptote is when you have x approaching a very, very big number. Vertical asymptote is when your denominator is 0. Okay, you really have to remember that. So here I have to set the denominator to be 0 and solving it. What I'm going to get is 2x squared minus 18 is equal to 0. Add 18 on both sides. I get 2x squared equals 18, divide by 2. X squared equals 9, x equals to plus 3, x equals to negative 3. So that's going to be my vertical asymptotes. Well, now the horizontal asymptote is when you plug in a very big number for x. Now I hope you remember that when I do that, the only thing that you want to care about is the very first term of the numerator and the denominator. Because even if you plug in infinity here, this 5 times x minus 2 is so insignificant to the infinity square that it's practically negligible. So what is 7x squared over 2x squared going to give you? Cancel out the x squared, I'm going to get 7 over 2. Or 3.5. Either one of them should be fine. Next, horizontal asymptote, vertical asymptote. Let's do vertical asymptote first because it's easier. Vertical asymptote should be just be negative 5. Horizontal asymptote is when x is a very big number. I told you to pretty much the other things are negligible. X over x is just simply 1. All right, let's do one more, which is this one. Horizontal asymptote and vertical asymptote here. Now, this one, x to the 4th minus 81, if you solve for it, you get x to the 4th equals to 81. X to the x then is going to equal positive 3. X then is going to equal negative 3. If you do 1 over 4th power, you should get x equal to 3. But remember, this is an even-powered function, so please don't forget you are positive and negative. Plus and a minus, basically. Now, horizontal asymptote. You're plugging in a very big number for x. What that would create then is that this negative 4 and negative 81 is negligible. So how do I do x squared over x to the 4th power? Well, if I simplify that, that's going to be 1 over x squared. Plug in a very big number for x. 1 over a very big number comes out to be just 0. Okay? All right, identify the vertex and concavity, concave up or concave down. The vertex should be very easy to solve for. It should be positive 1, 4, negative 2, negative 1. Remember, always flip the sign to whatever is in the parentheses. Then the concavity would be told by the very first number in before the parentheses. All you got to do is see if it's negative. That means it's concave down because your a value is negative. This will be concave up because a value is positive. I know that there's no number in there, but that means it's a positive 1 in there. And because it's a positive one, I don't care if it's 1, but it's positive, so it's concave up. Okay? All right, next question. Slide number 14, or question number 15. Given a graph, find the equation between the vertex and the testing point. We did this a long time ago by doing the basketball shot. So the vertex here is indicated at 0, -2. And the vertex, the testing point, you can use either P or Q, doesn't matter. I like to use Q because it might be easier. That's 1 and -1 right there. Okay, so the vertex format is y equals a times x minus a squared plus k. I'm going to plug in the vertex coordinate as such, and h value will be 0, k value will be -2. So y equals a times x minus 0 squared minus 2. Then I'm going to plug in my x comma y value into here. So the y value is -1, a times 1 minus 0 squared minus 2. -1 equals a times 1 squared minus 2. Now, where am I getting the positive 1 from is I'm plugging in 1 into the x, -1 into the y. -1 equals to a minus 2. Add the 2 on both sides. I'm going to get 1 is equal to a. So my final answer, because it's asking you to find the equation, not this entire gibberish, it's that y is equal to 1 times x minus 0 squared minus 2. Or to simplify, it's x squared minus 2. Okay? Next. The vertex here, I'm going to use red. The vertex here is indicated at, I believe, 1, 2, 3, -3, comma, -1. So the vertex h, comma, k is -3, comma, -1. And the testing point, let's just use this one here. Or actually it doesn't matter which one it is because they're equally annoying to do, I guess. -1, comma, 5, let's do that. Why not? That's your testing point. Okay, so if I plug all those in, -5 is equal to a times -1 plus 3 minus 1. I squared minus 1. I just simply skipped a lot of steps. I plugged all the x, comma, y values and the h, comma, k values into the vertex format, which is given to you right here. This is what you're going to get. So -5 is equal to a times 2 squared minus 1. Now, all of these things that you plug in just to find out the value of a, nothing else. So I'm going to add the 1 on both sides. -4 is equal to a times 4. And then the a value then becomes -1. So what is going to be my final answer is going to be that y is equal to negative times x plus 3 squared minus 1. All I got to do is just plug in the vertex and the a value into the equation, and that's going to be it. Leave your x and y alone. Those two will be the answer number 1, answer number 2. Next, solve each equation for the unknown variables. Okay, so systems, multiply this by 3 because I can get rid of the 9y. Doesn't matter. If you wanted to get rid of x, that's fine, but I like to get rid of y's here because it's easier to do. Cancel these out and get -x is equal to -9, so x is equal to 9. Am I done? Absolutely not. Plug it back in to the first equation or the second equation. Second equation seems easier. 9 minus 3y equals -6. Subtract 9 on both sides. I get -3y equals -15. So y equals to +5. So my final point will be 9, 5 as my final choice. Final answer. Next, I have x squared equals 3x plus 3. It's a quadratic, so I'm going to move everything to one side. X squared minus 3x minus 3 is equal to 0. I'm moving everything to the side where x squared is present. Can this be factored? Nope. Which means, what do I got to use? -b plus and minus the square root of b squared minus 4ac all over 2a. Quadratic formula is what you should be using. Then I'm going to say +3 plus and minus the square root of 9 minus 4 times 1 times -3 all over 2 times 1, which is 2. Why is this +3? Because your b value is -3. So 3 plus and minus the square root of 9 plus 12 over 2, 3 plus and minus the square root of 21 over 2, then that's going to give you my final solution. Okay? If you wanted to do actual decimal values, it should be 3.79 And then the other one should be negative 0.79. These two will be the solutions. Okay? All right, 17. All right, find the zeros of the cubic polynomial, long and synthetic division. So here, what I need to do is, this is going to be taking a long time, but I like to do synthetic divisions a lot more than long divisions. Take the coefficients of each, make sure that the degree goes in order, because if not, then you have to fill it up with zeros. 1, 9, 26, and 24. But remember what I always told you to use is try to use -1, +1, and those kind of sorts first. That's what I asked you to do. But since all these are positive numbers, I'm going to try -1 first. I can already see that this is not going to work out. So let's scratch that, and let's try to use -2 instead. And look at that, I have a 0, which gives you the remainder of 0. That means that -2 is one of my zeros. With these, I'm going to say that's x squared plus 7x plus 12. I can factor that really easily. So my final answer would be -4, -3, and -2. X equals -2, x equals -3, and x equals -4. That's my solution to the first question. Next, I'm going to be doing the same thing. And since this one has a negative number, I'm just going to plug in +1 and see what's going to happen. Okay, well that doesn't work out. It's not going to give me a 0. So let's try doing, I don't know, +2. Okay, so I got +2 to be one of my zeros. That's perfect. So this one can be turned into quadratic. And I can factor it very easily. So my final answer here would be x equals +2, x equals -6. Well, I +2 twice. I don't write that twice, right? I can just write that as having a multiplicity of 2, but my two solutions of zeros would just be at 2 and -6. That's it. Okay? All right, number 18. You have an antique watch that is worth 500. Each year the value depreciates at a rate of 15% per year. This, guys, remember, a times 1 plus r raised to the power of t. That's growth. A times 1 minus r to the power of t. That's decay. This is decay, which means I'm going to be utilizing the second formula. Write down the exponential model decay function that models this situation. Initial value, 1 minus 0.15, 15% in decimal 0.15, raised to the power of t. So same thing as saying taking 85% of the previous value every single year. Suppose that you want to find out how much watch is worth after t months. How would your exponential model decay look like now? So 500 times 0.85, now it's t months. But remember, it depreciates per year. So whatever the months is, I need to take, so what if it was like 12 months? How many years would that be? Well, that's 1 year. How did I get that? I take whatever the t months it's given to me, and I have to divide that by 12. Because if it's 12 months, if I plug in 12 here, that becomes 1 year, right? So I just depreciates after 1 year. Another way to rewrite this is 500 times 0.85 raised to the power of 1 over 12 times t, because that's the same thing as saying t over 12. 500. And I can just do 0.85 raised to the power of 1 over 12. 0.9865 raised to the power of t. Either one of these two, this one or this one, should make sense. Just keep in mind that you can have an answer choice that may look like this. Okay? So raise this to the power of 1 over 12 first, and then that should give you the number inside of it. Next, solve for x by using the same base. This should be simple enough. 3's the base is the same, so the exponent should be the same. X should be 3 over 2 or 1.5. Next, this one, the base is not the same, but so you gotta make it the same. 64 is 4 to the third power. 16 is 4 squared. How did you just come up with that? Nope, I gave you a long time ago I think in February and March. I gave you this perfect square chart where I asked you to do 2 squared, 2 cubed, 2 fourths, all like in a table. I gave you a small slip of paper. I asked you to write down all those numbers because I wanted you to recognize how 64 and 16, they're all perfect squares, perfect cubes, perfect quadruple powered. So if I were to rewrite them as having the same base, this is 4 to the third power, raised to the power 2x minus 3. This is 4 squared. You make sure you distribute them, so you get 4 to the power of 6x minus 9 equals 4 squared. This is equal to 2. 6x minus 9 is equal to 2. Add the 9 on both sides, I get 6x equal to 11, x equal to 11 over 6. Okay. Next question. What is the amplitude and the period of the following functions? Amplitude is whatever's in front of the sine value, so it's 3. Period is 2 pi divided by b. The b value is whatever's in front of x. So that means it's 2 pi divided by 2 over 33. Keep, change, flip. My final period for the first one should be 3 pi. Next one, amplitude is 4. Doesn't matter if it's negative, amplitude is still a distance, so it makes it positive. Period is 2 pi divided by 5, because you just have to divide 2 pi divided by the b value. If you have no idea what I'm talking about by a or b value, a sine of bx, a cosine of bx, that's the format that they're going to follow. The other components, the vertical shift, the phase shift, well, they're not going to be part of the equations here, but to get the final equation, so you get a sine of bx minus theta, which is your phase shift, plus k, or plus d, doesn't matter. But this is your vertical shift, this is your phase shift. But for now, just focus on amplitude and the frequency value. Next, find x. This is the trick questions I gave you a couple weeks ago. This is 60 degrees. That's your adjacent side. That's your hypotenuse. So what am I going to be using? Cosine of 60 degrees. That's adjacent over hypotenuse. To find x, I got to multiply 11 on both sides. So it's 11 times cosine of 60 gives you 5.5. Next, this one is angle 32. For respect to the angle, this is your opposite. In respect to the angle, this is your adjacent. So tangent of 32 degrees is x over 13. Multiply both sides by 13. You get 13 times tangent of 32. 8.1233 should be your x. And that should be the value for the opposite length from the angle 32. All right, next. Now, these two questions are a little bit tricky. This is not something that I went over with you in detail. It says, write down the corresponding negative angle that represents the positive angle. Your angle always stems from the 3 o'clock position. And if this angle indicated here, that's 135 degrees, well, the negative angle that's in respect to that should be, well, they both have to combine to get you 360. So to help you understand this a little bit quicker, if that's 135, the rest of it should be 225 degrees. But since we're moving in the clockwise direction as opposed to the counterclockwise direction, the counterclockwise direction always have a positive angle. Clockwise have a negative angle. So the equivalent angle of this should be negative 225 degrees. That's the negative angle that represents the same thing as saying positive 135. Now the thing is that you can do this many, many times. Positive 135 should be the same as going over 360 degrees more from that. So 135 plus 360 gives you 495 degrees. That is the same thing as saying the angle 135 degrees, because you go 135, then do 360 again, it should be the same terminal side or the same angle as what we have left before. So if we do this multiple times, we call this the coterminal angles. Coterminal indicating that because we end up at the same side. Easy way to remember this is, okay, I can't really zoom out from here. Easy way to remember this is, whatever the angle that you're given, do plus and minus 360 degrees, and that should give you the coterminal angle. So for example, the angle is 135. You subtract 360, what do you get? Negative 225 degrees, which is one of my angle. When you do 135 plus 360, it gives you 495. That's another coterminal angle to the same angle 135. And you can do 135 plus 720, which should give you the same angle as, it's the same coterminal angle as before, which is 855 degrees. All of these three angles ends up on the same side as 135 degrees. Okay? So when the question asks you to check off the boxes that indicates the same coterminal angle as 135, all of these should be checked. Write down the corresponding positive angle. Well, here, angle plus and minus 360. The angle here is 150 degrees negative. So if you add 360 to that, what you're going to get is positive 210 degrees, and that's going to be this one right here. Okay? I'm sorry, wait a minute. But then this thing is that, I guess this one's indicating positive 150. So, because this angle right here should be going from the 3 o'clock position to here, which is positive 150. So, yeah, that should be positive 150. So positive 150 plus 360 should give you 510 degrees. That means that you go here, 150, go 360 one more time, that's 510. Another way to write this is 150 degrees minus 360 degrees, which gives you negative 210 degrees. That's this angle right here. That's negative 210. But since we're talking about the positive angle that indicates that, that's going to be 150 degrees or 510 degrees. So any angle of the following, 150, 510, negative 210, they all end up at the same coterminal side, so all of those three should indicate the same terminal side, which ends up being right there. Okay? Alright, so hope this video helped. I know that this last part is a little bit shaky, so please just understand that that is the formula, and that's all you have to remember. Theta plus and minus 360. And this is all dealing with coterminal angle. There's only one question that deals with this topic. So, and just checking off the boxes. And I don't think you should have too much trouble as long as you remember this formula right here. Okay, this is comprehensive review video. As long as you did all of these questions by yourself and go over this video, there shouldn't be any problem with doing the final for tomorrow. Remember, 30 questions. 30 questions, and it's all on Pearson. Okay, so everything that we have talked about in this video will be those 30 questions on Pearson. That's going to be it. Okay, so hope this video helped. I hope you enjoyed the class for the year. Have a safe and wonderful summer vacation.